So for this video, I am actually going to be doing the task. I am not going to be in class for the next 3 days. I'm at a conference in Monterey, and we don't have the time for me to just give you guys busy work for 3 days. So you will be working. We're going to do these tasks a lot more traditionally than what we've been doing in class. I'm not going to complete the entire task for you. I will expect you to do some, but this is your classwork for while I'm gone. So you're going to be watching this video. You're going to be doing the task. You can pause it, do the task at the same time. You're doing this in class. All of 2.6 you're doing in class today. If you don't finish it today, you are going to continue watching it tomorrow and start working on the 2.6 ready, set, go. So Wednesday and Thursday needs to be dedicated to 2.6, and then Friday will be dedicated to 2.7, at least starting it. But you'll have the whole video for 2.6, you'll have the whole video for 2.6 homework, and the whole video for the 2.7 task that you guys are going to need to watch while I am gone, and those 3 things need to be done before I get back. You will also have the 2.7 homework video that you guys can watch over the weekend. So hopefully we'll be able to just pick right up on 2.8 when I return, but I may need to dedicate some time for questions. So as you guys are working through your tasks and your homeworks, I need you guys to highlight something, make it stand out, the things that you do not understand and that you're going to need extra help on. All right, so let's get going on this. So, compounding the problem. This is all about how can we actually take logs and use them in the real world to help us solve some situations. And it may not always be a log that you're using. It may be an exponent. Remember, logs and exponents, they go together. They're just written differently. You're going to be given formulas, so that's nice. You're definitely going to want to make sure that you know this one. This formula is used when you have compounded interest. And it's going to tell you how the interest is compounded. So here you have what your different variables are representing. P is the principal, the starting amount. R is your interest rate. Your interest rate is usually given to you as a percent. So make sure you change this to a decimal, which means you have to move to the left 2 times, 2 spaces. You have to move your decimal before you can plug it in. Here's the tricky part. T, number of years, that's easy. It's going to tell you that. But in the number of compounding periods each year, you will have to know, and you're going to want to write this down. Ignore that stuff. You don't need that. Let me erase that. I didn't know that was over there. Okay. If it says annually, that's once a year, so your N will equal 1. If it says semi-annually, that's twice a year, N equals 2. Triannually, 3. If it says quarterly, N will equal 4. If it says monthly, N equals 6. Oh, I don't know why I put 6. 12. If I see daily, N is going to equal 365. And on and on and on. If it's weekly, N will equal 52. So it's just how many times that occurs in a year. Definitely write that down on a post-it note and stick it in your book. So now you're going to go through and you're going to use that formula to answer a series of questions. If your savings account pays a generous 5% per year and is compounded only once each year, how much money would be in the account at the end of 1 year? So, my time would be a year. My rate would be 0.05. Compounded once a year, n is going to equal 1. Now my principal amount is given back here. Oh, this thing is irritating me. In this paragraph, we have $100. So our principal is 100. So now you're just plugging in. So it's 100 parentheses 1 plus your interest rate divided by your n to the nt. So this here, I know it doesn't really look like it, but that is an exponent. So now it's just using your calculator. Please practice using your calculator. I'm going to just put the answer. I'm not going to go through all of the work here. But 0.05 divided by 1 is just 0.05. Then I'm going to add 1. So I'm working inside the parentheses first. Then I have an exponent of 1. So that's pretty easy. I don't have to do much there. Then I take my whole answer, which is 1.05, and I multiply it by 100. So I have $105 in my account after a year. Practice getting that in your calculator, or at least understanding where that's coming from. Because in number 2, you're changing your T. T is now 20 years. 100's going to stay. 1 is going to stay. 1 will always be there. It doesn't say it's compounded differently, so we're going to go with once a year and once a year for 20 years. So, in my calculator, I would do 0.05 divided by 1, hit equals, add 1, and I get 1.05. So this is 1.05 caret 20. So 1.05 caret 20, and I get this crazy decimal of 2.6 something. Make sure you get that. Then I have to make sure I remember to multiply this by 100. So in my calculator, I can just type this in because I don't have any crazy decimals. I could just type it in with that right there. Just don't forget to use parentheses. But otherwise, it's going to get ugly. You don't ever want to cut off a decimal. You want to keep using the entire decimal. So just get used to putting this in chunks, unless you're very good with your calculator. If you are not, don't do this in steps, please. Don't do this at once. So I'm going to take my answer, the 2.6, and then a bunch of decimals, and I'm going to multiply it by the $100 I started with. So after 20 years, there will be $265.33. And I round to 2 decimal places because it's money. So make sure you can get that in your calculator, please. All right. So now it seems like the more compounding periods in the year, the more money that you should make. The question is, does it make a big difference? So what you're going to do now, and I am not going to do this for you, what you guys are going to do is you're going to compare the amount of money for 20 years. So you're going to use T equals 20, your principal is 100, your rate is 0.05. Your N is what's going to change. So you have to do this multiple times. You're going to go first with semi-annually, then quarter, and then 12 times. Actually, let me use a different color for each one so it stands out. 4 times a year, 12 times a year, 365 days a year, and then hourly. Have fun with that one. You need to figure out how many hours there are in a year. So if there's 24 hours in a day, 365 days in a year, that's your new N. So you're going to have to do this 5 times. 1 when N is 2. And it does say organize your work. You might want to do this on another sheet of paper. 1 when N is going to equal 4. You have to do 1 when N is going to equal 12. You're going to do 1 when N equals 365. And then you're going to do 1 that is 365 times 24 when N is 8760. What I would like you guys to do with this problem is take the time to work through all of these and then check with your group. Do you guys all have the same answer? And if you guys are struggling, maybe somebody who's getting this can go up and show it to the class, or at least put your equation on the board for everyone else to see, and then maybe they can kind of compare your work with theirs. All right. So that's the first part of this task. Now we're on to the second part of this task. It turns out that the value you found in your compounding problem is 100 times a very famous irrational number named E. And this you guys would have seen on your calculator. You do have this. Like pi, E has its own value, 2.7 and a whole bunch of numbers after it. So they already have this algorithm in your calculator. And then this is used to find interest that is compounded continuously. So that's the difference here. It is forever getting interest, whichever account that you are plugging into, where here it only happened so many times a year. This is continuously. It's like infinity. Your account is always getting money no matter what. P is still your principal, R is still your rate, T is still your time. But now E, this is where everyone gets confused. Every year I've taught this. E is the button in your calculator. You don't need to type in that super long decimal up there. It is above the ln or below the log. So find the E button on your calculator. It says e to the x. That is what you'll be using here. So here we go. It's very typical for savings accounts to be compounded monthly. That's mine. I get like a penny or two a month. I wish it was continuously. Compare the amount of money in 2 savings accounts after 10 years. So that is my time. With the same initial investment of $500. So I'm pulling out all the important information. 10 years, $500, interest rate of 3%. So let me write that. So that's 0.03. In each account, if the first account is compounded monthly. So account number 1, monthly is 12 times a year. Account number 2 is continuously. So you use the A equals PE to the RT. For account number 1, you're going to use the formula that you used back here. So we're going to plug in to the A equals P times 1 plus R over N to the NT. So I'm going to let you guys do that. I'm not going to go through and do that, but then you need to check with your group. Make sure you guys are getting the same answer. That's how we would be doing this if I was there in class. So you guys would be going through and doing all of this work. Check with your group, please. Make sure you are not making mistakes. One thing when you guys are using the PERT formula, please use in your calculator the very first step should be E caret parentheses R times T, and then close the parentheses. Once you're done with that, you're going to hit equals. Then your second step is going to be whatever your principal is. So you're going to hit times, and then that's when the ANS pops up, and then you're going to multiply it by your principal, and then you can hit equals. Every year I have students who cut off their decimals, or they plug in incorrectly and they don't use parentheses. Something went wrong in their calculator because of how they plugged it in. If you are off by a couple of pennies, okay. But if you're off by 50 cents or you're off by $1, that's not okay. That's a mistake in your work. You should not be off that far. So please do not round your decimals. Keep your decimals in the calculator. Use the answer button, please. Do not ever, for example, if you guys saw this super long decimal in your calculator, you guys would be lazy and you guys would just go 2.72 probably. Well, you just left off a whole bunch of numbers and that's going to give you a different answer. So please don't cut off any decimals as you guys are working through this. All right, moving on. When it's saying use technology to compare the graphs of the two accounts, you're welcome to go into Desmos and look at this. I am really not worried about that. Only if you want to. If I was there, we would, but just for time's sake, and it's not something you guys really need, we'll just ignore that. But if you want to play around with Desmos, go ahead. All right, next part. You are now going to move on to graphing e to the x. So remember, e is a value, 2.718, and then a bunch of numbers after it. We use this for growth and decay. It's an exponential function. Growths look like that. Decays look like that. My graphs are really rough. Just go with it. You guys are going to make a prediction about what you think this graph is going to look like. Do you think it's growth or do you think it's decay? Now make a prediction before you graph it. Now, I do want to see you guys creating a table where you have your x and you have your y. And I would like to see you pick -2, -1, 0, 1, 2, and let's just go with 3. So your y is e to the x. So you're going to need to use your calculator and you're going to plug in and get your values. So e to the -2, and I'll do this first one for you. So I'm going to go to my calculator. I hit the second button so I can get the e, and then I'm going to put -2. And this gives me 0.1353 and a bunch of other things. So at -2, I'm barely above the x-axis. And then continue to go ahead and work through the rest of these and make your table. Now when it's asking you to list the features of this graph, I was just seeing how much is left. Talk about if it's increasing or decreasing, which means if it's growth or decay. Talk about intercepts. Talk about domain, range, and there are no max and mins. Maybe talk about an asymptote that you might see and be specific. Maybe draw it in. Use a highlighter and draw in your asymptote so you can see what an actual, so it's just exponential. You guys did this in Math 1, but it's been a while. So this is the ultimate exponential graph with e to the x. That is your exponential. So that's really all you need to talk about there. And that'll wrap up the 2.6 task. Whatever you are not getting, please make sure you highlight it, star it, so you guys can ask me on Monday or ask your group. There's probably somebody in your group that might be getting this or hopefully getting this. It's not difficult stuff. It's just plugging into formulas. So I'm really counting on you guys to being able to get this. All right, when you are done with this task, it is time to start working on your ready, set, go. So now that's the video you're going to go to. and I'll see you there.